Welcome back, students, to CERT-In session on Zero to Hero on an assembly language, the language of Cyber Defender. Day 5, the final day. Today, we'll be addressing some of the most important fundamentals of assembly language, which will help you be on your journey to becoming a true Cyber Rakshak. This course is taught by Cybervidyapeeth Foundation. We are an education and research as well as training entity dedicated to cyber defense engineering. This is Professor Xerox. I have been taking your class for the last 4 sessions. As I said, this is the final session. So let's get started. Today we'll be talking about a few concepts. Here's the first one, dividing and conquering. So some interesting things that we need to note right now about different kinds of codecs. Okay. And these are very simple things, but these can get more and more complex. So the first thing I want to talk about is ASCII notation versus Unicode notation, and then we'll talk about the APL notation. So the ASCII notation is an American notation system. It's one of the oldest. It's also one of the most widely adopted notation systems in the world. It stands for the American Standard Code for Information Interchange, and it's extremely popular. It's a standardized way. And there's another one. So we have one more extremely popular character set, which is called the Unicode, which basically is a short for universal character set. Now, Unicode is much bigger than ASCII. ASCII only has English plus some Latin letters and some symbols. But Unicode has a massive number of characters that you can use. Managing complexity is a great challenge in programming. Yes, that's very much true. Key to this skill is something that sounds like Eastern mythicism, which is really just observation from life. Within any action is a host of smaller actions. Pick up your toothpaste tube, unscrew the cap, place the cap on the sink counter, pick up the toothbrush, squeeze the toothbrush. Okay, so I think you get what I'm talking about here. Anything in life is divided into much smaller steps, and then that step might also be divided into two smaller steps, and it's really hard to reach the bottom of these steps. When you think about what's behind an action we call getting up in the morning, you might assemble a list which looks something along the lines of this. These are definitely lists, but this is a category rather than smaller options when you're following instructions or steps, right? So sometimes you need to break them down even more deeper. And this is something that I want to really discuss right now, that many times there are topics or instructions in assembly that might get too complex for a single line. So you might have to break them down into multiple lines. Same way, when you're programming in assembly, I want you to think of a logic as multiple lines to begin with rather than a single line. This is something a lot of the high-level language programmers, such as Python programmers or Java programmers, don't do. Is what they think is that, I will have 3 lines of code. I will write my entire logic. I disagree with that logic, and I think, it's better to have more lines of code which are descriptive in nature with comments rather than having a single line of complex code that does the same work. If there's any questions till now, please feel free to ask. Good evening, everyone. So let's go ahead. No question. We can also have specific types of procedures as boxes of code. Again, this is connecting you to the topic of subroutines. Again, this is standard college theory. Not going too deep in here, so you can actually just pause your screen right now and just go through it. There is a talk of very simple software such as OpenOffice here, so you can look into that. Again, you can pause and go ahead and have a look at this file. We have already seen call and read, so I'm not going to waste too much time here. So in this diagram, you can see that we are calling and then we are returning. Again, calling a procedure and returning, you can see this is not too complex. We've seen this before. Here we are talking about the clear line. You can look at the different code and don't worry about these file names. Okay, all these ASM source code files will be given to all those students who have registered with us, and this will also be available at our centralized Bitbucket repository. So all the code will be available to all of you. Let's talk a little bit about the dangers of accidental recursion. So what here they're telling you here is that, say that a function calls itself, right? And if that happens, then the return address is usually not removed from the stack. Many times what happens is that recursion can cause a lot of issues at the low level. For example, if you are developing an operating system, one of the ways we judge if your operating system is quote unquote mature to be deployed in enterprise environments is by looking at how it handles recursion in programming logic, right? It's how it's able to call its own function. Point number one. Point number two, how it's also able to handle its memory. That's extremely important, because if it's not able to handle its own memory, then that's going to cause a lot of issues down the line. Here's a simple code. Please have a look. I mean, it's pretty self-explanatory what it does, so I'm not going to explain too much. Again, some theory for all of you. Please just go ahead and read start to finish. You can pause the video right now. We have already talked about caller, callee, and register savings. Here's a simple example again. Please pause the screen to learn more. Again, you can pause the screen to learn more. Don't worry about the program references. All program code will be shared on our GitHub. I mean the Git server. The Git server will be shared with all of you through YouTube community post soon, as well as the Telegram group. So please make sure that you are subscribed to our YouTube channel and that you are following us on Telegram to be updated on the code part of things. Stallman, as you might know, had his own variant of Unix GNU, an acronym for GNU is not Unix, which is a recursive acronym. He founded the Free Software Foundation, which serves as a hub for creation of GNU tools, and the GNU Public License, GPL, a radical form of software licensing that is commonly referred to as copyleft. In addition to referring that programs be free containing full source code, Stallman published the GNU tools under GPL, which forbade users from making small changes to the software and claiming derivative of work as their own. However, the GPL has made it possible over time because so many individuals are using, enhancing, and contributing to GPL licensed software. It evolved incredibly quickly. Linux improved without the cost or restriction. Linux was built with the GNU toolkit, is now maintained with it. Some things to know about GCC is that GCC is like a stack, and GNU GCC, is just one of the examples of the stack. So GNU utils have actually a lot of things in them. You can have, GNU-D, GNU-C, GNU-C++ compilers. You have Rust compilers, GNU Rust. You have a lot of them. So let me quickly just take you through the GNU landscape in about a minute. I'm going to share my screen now and show you just a very small example of what I'm talking about. So now my screen should be visible. Right. So here's the PPT, and I'm just gonna type in GNU utilities. So here you can see the GNU utilities. Now GNU utilities have many different sections and individual utilities as well. But if you're talking about, all the different language compilers that come in GNU, then you can actually just type GNU C++ compiler, just like so. And it's going to take you to GCC GNU collection because GCC handles both C and C++. There's also one for Rust. So you can type GNU Rust, right? And it will tell you that GNU Rust is a thing and that there is a compiler tool chain for GNU, as you can see here in this message right here on Stack Overflow. There's also, GNU utilities for languages such as Golang. So you can actually do GNU Golang, and you will find that GNU Go is again a project. So GNU actually does have, in many cases, separate projects to handle this kind of separate development behavior. Now, just for a few seconds, let's talk a little bit about how the code is built using GNU. Again, this is not about GNU, this course, I don't want to waste too much time in GNU, but these are some concepts that we'll be ending assembly with. So I wanted to go a little bit into them. So work done in assembly language differs from work done in C. And GCC is primarily a C compiler. For a number of GNU tools, GCC serves as the master controller, managing an assembly line of code. Need to generate an executable binary from source code, you can do GCC eatc.c and you can output eatc file. Here GCC takes the file eatc.c, which is a C source code file, and crunches it to produce the executable file eatc. The -o or output option tells GCC what to name the executable output file. Here you can see a simple diagram on how it happens. So you can now pause your screen and just have a look. Now, there are ways to use GCC for assembly work. So you can use it for assembly language work. And NASM creates a .o or object file containing the binary object code when assembling a Linux program. Invoking NASM under Linux is typically done using NASM-FL-G-F stabs and then the name of the assembly language file. The command instructs NASM or the netwide assembler to assemble the assembly language source code file to produce the object file. Instead of one of the many alternative object code formats that NASM is capable of producing, the -F ELF component of the command instructs the netwide assembler to generate object code in the executable and linkable format, which is supported by Linux and BSD. The -G-F stabs component permits generation of stabs formatted debug information in the output file. The eat clib.o file or any object file for that matter cannot be run on its own. It must be connected. Therefore, we call GCC and instruct it to link the program for us. What phrase in this instructs GCC to link it to the compiler? An object containing .o file is the sole purpose as an input file mentioned in the command, meaning that we take the object code and then we pass it into the linker for more benefit from it. A lot of people might be asking a simple question, why not use gas or the GNU assembler? So, I have been bothering you with the NASM assembler. I've been saying NASM, 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 right? Why? So the syntax of GNU assembler gas is odd and completely dissimilar from that of any other well-known assembler using the x86 word, including NASM. It contains a comprehensive collection of proprietary instruction mnemonics. They are difficult to read, unattractive, and without any sense. This is AT&T syntax, so named because AT&T developed it as a portable assembly language to make it similar to port Unix between different underlying CPUs. Because it was created to be general and adaptable to any conceivable CPU architecture, it is ugly in part. More specifically, we believe here at Cybervidyapeeth that the idea of a portable assembly language is an absurdity. An assembly language should reflect the underlying machine architecture accurately, completely, and directly. So this is one of the reasons I'm not using GAS, the GNU assembly language compiler. Here is the simple process of linking. Here you can see how we link the programs. Again, this is a very simple diagram. If there's anything you don't understand now, please feel free to ask me. Just going to pause here for 2 minutes so you can go through the entire part of the diagram. Let's move ahead. So many times when you're setting up a stack frame for functions, there is some setup required. Here's a very simple example of how a stack frame is set up. Again, I'm pausing the screen here so you can actually go through this diagram and please make sure that you understand it. If there's any questions, feel free to ask. Go ahead. I want to discuss a little bit about divide and unsigned divide. So here you have divide. First of all, it has 3 forms, or div, right? Again, this is an assembly instruction. And this will be available to you in mulDivideExample.c code. So you'll be able to have a look at this in the code that we'll share. It has three forms. You can see it has the RM8, the register to register RM32, and then the bigger register to register RM64. So you can use 8-bit version, 32-bit version, or 64-bit version for div. And it allows you to do unsigned divide, storing the quotient in AL, the remainder in AH. In the second situation, it stores the quotient in EAX of the division and the remainder in EDX. And in the third case, if you're implementing it, it stores the quotient in RAX and the remainder in RDX. You can see some very simple diagrams below to give you an idea of how this instruction works. This is one of the only few basic instructions that we'll be looking at in this course, so make sure that you're understanding what it does. Now let's talk about signed divide. So if we put the IDIV instruction, we are able to do signed divide. There are three forms to signed divide. Again, you can do it RM8, RM32, or you can do RM64. If the dividend is 32 or 64-bit, EDX and RDX will just be set to 0 by the compiler before the instruction executes. If the divisor is 0, a divide by 0 exception or trap or interrupt is raised. Again, you can pause the screen and have a look at the diagrams for more information. Now, let's talk a little bit about how an array looks and how we reference something inside an array from C to assembly. Here you can see the rep stos instruction being used with a byte pointer to the location stored in RDI register. Please feel free to pause the screen again and note down the assembly language code as well as the C code so that you can trace the code with your own hands by using dry run methodology. Now let's talk a little bit about mathematics. So here you can see a simple program. It does basic mathematics, right? Nothing too complex, but it does, this mathematics in computers. So we see the C program right here. We are using the standard library. And on this end, we see the LEA instruction being used. This is what is causing this special math to be executed. Please pause your screen and write this down so that you can trace this as dry run code. Now let's talk a little bit about the last few instructions that we'll be looking at. So the first instruction that I want to talk a little bit about is the LEA instruction. The LEA or leave instruction, it's usually just exit a function. It's literally, the same as the last two instructions you'll anticipate before seeing a function using stack frame returns. It's used a lot. You also have conditional moves, which we have talked about a little bit. These are different forms of move. Then finally, you can see 0 initializing the array. So if you remember, there is this thing you can do in C where you can initialize an entire array by using zeros. This is how it looks when you get inside assembly language. You can again pause the screen to have a look at it. this is how the stack looks like. Okay, when you're doing zero initialization, you can just pause the screen and go through. This is showing 64-bit memory, not 32-bit memory, just to be clear. Now here's something extremely important and interesting. Let's talk a little bit about Intel versus AT&T syntax. So Intel syntax is preferred on Windows, and it's like basic algebra. You do y equals to x plus 1, something like this, right? Where destination is written first and then the source, right to left. Example is move RBP RSP, which basically means take the value stored inside RSP and put it inside RBP. Okay. Now, this is the question, right? How does AT&T work? So this is preferred on Intel Linux and GNU based OSs. BSD prefers Intel or AT&T depending upon which BSD you use. You can think of this as elementary school. So 1 plus 2 equals 3. This is like source to destination. So source is written on left and destination is written on the right. For example, move RSP RBP. Don't worry about the percentages. That's just how you write it in the AT&T, which means that the values inside RSP should be moved over to RBP. And when I say move, I mean copy. Registers get a percentage prefix, and immediates or static values like numbers get the dollar sign. That is the reason you see 14 hexadecimal here after the add with a dollar sign in AT&T syntax. There's some other instructions for AT&T. I will let you just have a look at them right now and won't go too detail, as these are some advanced instructions that we won't be saying throughout this course. Please pause your screen and have a look right now. If there's any questions, feel free to ask me before I continue. Some students are asking the main difference between NASM and GAS. GAS is just having a much more complex way of writing assembly code, for beginners at least. It's also designed to be somewhat portable assembly, okay, which the concept of assembly itself breaks in when you talk about portability, right? You cannot make assembly language cross-platform. Assembly is supposed to run on a specific, processor or type of processor. It's just how it's designed from ground up. So GNU and GAS haven't really done a great job. I mean, you can still program, and if you know what you're doing, your program might even be cross-platform across maybe 2 or 3 major platforms, but it's much harder to code in. It uses the AT&T syntax, not the Intel syntax I've been teaching you, which is a lot more complex and unintuitive, if you ask me. And overall, it's just a hassle. So a lot of people prefer MASM and NASM. And let me show to you what I'm talking about. So let me open up Google and let me just go ahead and share my screen so that you can see Google. There we go. In Google, I am going to search for MASM, right? So MASM assembler, right? And let's try to understand a little bit what MASM is. So Microsoft's macro assembler is, you know, is really powerful, and it was inspired from NASM only, network assembler. And it contains a macro language that has features such as looping, arithmetic, test strings processing, and gives you greater control over the hardware. So if you're dealing with Microsoft systems, right, then you should probably be using MASM to compile your code. This is not to say that your assembly instructions written for NASM running on Windows are not going to work. Just so you know, NASM assembler also works for Windows. So I can actually do NASM assembler Windows, and it does work. Net-wide assembler right here does work for the Windows operating system. It is just that so there you go, Windows 64. There you go. Here's the installer for NASM. So NASM does exist, and you can download the installation package and install NASM assembler on your system. But it's just that installing it doesn't change a lot, okay? Because again, as I said, Microsoft Windows has made MASM, which does some other proprietary magic in the background with Windows to make your applications much more optimized. Now, I mean, you can say, to the hell with Microsoft, I'll make my own things in NASM, and it'll work, right? If as long as you're following conventions from Microsoft website, you'll be able to write your own assembly language code even for Windows. That is possible. But usually NASM is used on the Windows, on the Linux and BSD side, and MASM is used on the Windows NT kernel side. If there's any other questions, please feel free to ask. It looks like there aren't any questions on YouTube, but there's a few in the group, so I'll start asking them. The first question is, sir, what is the difference between a compiler and a assembler? So compilers nowadays are more like compiler plus linker plus assembler plus object file parsing tools plus debuggers all at once, okay? If you're talking about assemblers, usually assembler is just the assembler that lets you do the assembly. When you're dealing with compilers, a lot of the assembler and linker function is handled automatically, so you don't have to worry about it. For example, if you're using GCC, but if you're using something like NASM, the net-wide assembler, then you might have to do all of that manually. Not might, it's basically you have to do it yourself. And you can use the LD command to link your object file. There's another question that there's another question that's being asked that, sir, if I know Linux assembly, how much time it will take me to learn and grasp Windows assembly? Well, it depends. Windows assembly is usually a little bit more complex because of a lot of the graphical libraries, low level libraries being introduced. But I would argue if you are putting in the hard work, you can learn Linux assembly in about almost a month and a half if you're really working hard on it. So yes, that is a possibility always. Another student asks the question, uh, if you're unable to see these questions, don't worry, these are being asked to me privately on my Telegram, so you might not be able to see these, but I'll still answer all of them. So there's another question here. It asks, sir, is it possible to learn exploit writing after learning assembly? Yes, very much so. As a matter of fact, assembly language is the entry point to exploit writing. I've covered that in the first day. So if you were worried about all of that, please go back, watch day 1 and day 2. Sir, can you explain how state-sponsored actor targets work? Okay. So mostly what happens is that, any state-sponsored group, any cyber group, state-sponsored, they usually have their own stack. Many times they code in assembly or some custom language, which they have a lot of control on because they have developed, and then they build libraries on top of it, and then they optimize it using assembly. Many times, if they're good enough programmers, they might actually write the entire thing in the assembly language of that CPU architecture, which they use quite a lot. Okay, there's another question. Sir, how can I use persistence on Windows using assembly? um, that is a very, very complex question, and a really, really advanced question, which is not covered in this course, and it will take me hours just to get the basics down. So if you wish to learn complex topics such as this, I highly recommend checking out our post-graduation diploma in cyber defense, taught by Cybervidyapeeth University, and organized by Vinoba Bhave University in association with University Grants Commission of India and Government of Jharkhand. Any other questions? Feel free to keep them standing. I'll be more than happy to answer you. Sir, is it possible to get jobs in assembly language? Yes, very much so. Assembly language programmers are paid quite a lot in the industry for all kinds of work, from game optimization, especially in the mobile gaming side. If you remember when PUBG got released, a lot of developers were hired to optimize PUBG to run on low-end phones to get 60 frames per second when PUBG got released on mobile. We have quite a lot of similar incident happening recently. So yes, assembly language programmers are in demand for a lot of things. Low level optimization for Python. Yes, sure. So you can actually do low level optimization for Python pretty easily. And I would like to just introduce the platform which you can use to do so. Again, we cannot cover it in this course. If you wish to learn it, please join our PGDCD. But it is my duty to share that knowledge with you. So there you go. Here you can see Python C extensions, also known as CPython, which is an optimizing static compiler for both the Python programming language and the existing CPython programming language based on Pyrex. It makes writing C extensions for Python as easy as Python itself. So this is an extremely powerful way of optimizing your Python code or your Python libraries that you're developing, especially for data science applications. So I highly recommend you check this project out if you're talking about optimizing Python at a very low level. Again, this is not covered in this course, but it is my responsibility. So I'm disclosing this to you so you can have your own research on the topic. Please subscribe to our channel, like and share this course so that people can have access to all this free knowledge and that they're able to learn and grow from all this learning. Also, please make sure to check out our course post-graduation diploma in cyber defense, also known as Cyber Rakshak Advanced, taught by Vinoba Bhave University and Cybervidyapeeth Foundation, Faridabad, backed by Government of Jharkhand and the University Grants Commission of India. You may join our Telegram group for more information by scanning the below QR code, apply now, or connect with us through our Connect Us form. You may mail us at mentor@cybervidyapeeth.in or go to our website on www.cybervidyapeeth.in or call us on 971-114-7900. Please do not worry about the admission ends on 31st October 2022 message. The timeline to apply for the course has been increased due to increase in demand and a lot of students signing up recently. So there's a huge line of students, and it is going to be fantastic to have you also on board with us in the course. We will be discussing extremely complex topics like malware development, C2 framework development, developing your own platform and language, compiler design, compiler vulnerability fuzzing, and a lot of other interesting topics throughout the PGDCD. So please, if you're interested, definitely check it out and join us on Telegram so we can help you understand and grasp the content more. Thank you so much for joining me for the last day of CERT-In session on Zero to Hero in assembly language, the language of Cyber Defender, day 5. Please make sure to contact us on mentor@cybervidyapeeth.in with any queries you have. Please just format a mail and send it to us. We'll be sure to reply to you. You can also mail us at info@cybervidyapeeth.in. You can contact us on 9711147900. Thank you so much for joining me for this great course and this great session. I wish to see all of you there in PGDCD with me, where we'll be going far deeper into the depths of assembly language and trying to understand what can be truly done. Some people have been asking where assembly language is mainly used. It's used in a lot of places, but usually where there is a lot of resource restriction. So resource restriction would mean, embedded devices like ATM software if you want to design, or satellite software, critical applications, rocket software, right? Missile software. So these kinds of places also you will see assembly language being used a lot and optimized a lot. Of course, these are very specialized cases, and assembly is usually really optimized in such cases. When would the registered classes for PGDCD start? So the classes will start soon. Please make sure that you are in our group. We will tell you about 7 days before the classes start, so you don't have to worry. You will have ample time. We will also make sure that all of you have all the resources, tools, software, and access required, such as access to our simulator, among other things, to start the course. If there's any other questions, feel free to ask me. I'll be here in the meet for a few more minutes to answer all your questions regarding our other programs and the trainings that we do. So there doesn't seem to be any questions. If you have any doubts regarding financing, how to join the course, how to apply for it, what are the things I'll be learning in a little bit more detail, you want access to brochure, or any such questions, feel free to mail us at mentor@cybervidyapeeth.in and we will respond to you at the earliest. Thank you so much for joining me through this course. I hope you learned a lot about hacking, assembly language, CPUs in general, and about logic circuit boards. Till next time, see you guys soon. Dhanyavad and Jai Hind.